Okay, so our next and last speaker is Professor Perotto. Simona is professor here at the Department of Mathematics in Politecnico di Milano. She received her PhD in computational mathematics and operation research here at the University of Milan. She is a recognized expert in the study of numerical methods for a solution of partial differential equations, in particular from the perspective of adaptive methods, and in particular on anisotropic adaptive methods. Recently, she obtained very interesting results in the context of topology optimization. But in addition to her intense research activity, she started a new adventure. And she is a co-founder and president of Adapta Studio, which is the second spin-off of MOX20, and now she's going to describe this great adventure. Yeah. Please, Simona.
Thank you, Marco, for your kind introduction. Good afternoon to everybody. First of all, I would like to thank Alfio for the kind invitation, for inviting Adapta Studio to this celebration. It's a great honor for us to be here. So everything started with a teapot. As you know, this is the very well-known Utah teapot, the first 3D graphical object in the history, made by Martin Newell during his PhD in computer science in the early 70s. But actually, this is exactly the same statement we adopted as opening phrase during the first pitch at Switch to Product, the innovation challenge organized by PolyHub, the Innovation Park and Startup Accelerator of Politecnico di Milano, by the Technology Transfer Office of Politecnico and Deloitte. We attended this selection in 2019 with a project named Amazing. Actually, everything started a few months ago. With the discussion of the master thesis in mathematical engineering by Leonardo Locatelli and Francesco Clerici that I supervised. The topic of these two theses was mesh adaptation for image segmentation. So you find a keyword mesh adaptation that Luca cited this morning among the tools to be employed to tackle practical problems nowadays. So starting from this day, we started to think seriously about and to work on the idea behind our proposal of project at Switch to Product. All right, so we are talking about 3D graphical object, and the challenge we faced is to find a smart way in order to reduce the number of polygons describing your 3D graphical object while preserving accuracy. So we are coming back to the trade-off cited before by Professor Estaven between accuracy and efficiency, when here efficiency has to be meant as a light object. And if you want, we are also coming back to the saving of data that Alfio and Emilio cited this morning, because with this algorithm, the algorithm that we devise is we are reducing the weight of our 3D objects, so we are saving data, all right? So here you have our favorite 3D asset, the chameleon. So on the left column, there is the original object with the corresponding number of polygons and weight in memory and level of detail. In particular, this is LOD0. In the other two columns, you have two examples of optimizations, an intermediate one and an advanced one. In both the cases, as you can see, we are able to reduce the number of polygons and, as a consequence, the weight in memory, but essentially we are preserving the accuracy, both with LOD1 and LOD2. Besides the geometry you have to reduce, you cannot forget the texture that you have on your object. So this is another challenge that we had to face. So For this reason, we devised advanced mathematical algorithms in order to project, the original texture on your objects onto the reduced asset. Here you have two examples associated with two levels of reduction. Nefertiti from the well-known Stanford Library on the top, and a model of a shoe on the bottom. And as you can see, in both of the cases, despite the level of reduction, of optimization as you want, we are able to exactly project the texture on the reduced objects, and we are also able to preserve details. You can look here, the name inside. By the way, all the mathematical algorithms that we have devised for both to tackle the geometry and the texture projection have been filed for a patent. All right, so in December 2019, Amazing Project was among the 20 winners of Switch to Product. And as a consequence, we started the acceleration program organized by Polyhub. 3 months later, we obtained the first funding proof of concept grant by the Capital Venture 360 Capital Partners to cover 1 year's work. The pioneers of this amazing experience were Leonardo Locatelli, who is here in the public, myself, Matteo Carbonara, who is a mathematical engineer student, and Francesco Clerici. During this month, we had also several mascots, the Pokemon Pikachu, Lara Croft from Tomb Raider, and Keanu Reeves from the video game Cyberpunk 2077. They all attended all the selections we did, since they provided us an interesting example to show the potentialities of our algorithms. Okay, during the first year, we performed a very tough market segmentation. So essentially, we identified a certain number of applicative fields where our algorithms might be useful. So cultural heritage, Industry 4.0, medicine, e-commerce, and gaming. At the end of the day, we decided to focus on one of these fields, in particular on the gaming market. This means 3D video games, if you want more into the details, photorealistic and photogrammetric game assets, AR, VR video games, and more recently, Metaverse. All right, so the months between December 2020 and February 2021 have been very tough months for the Amazing Project. The key point was to understand if it made sense or not to go on with the project. If there were actually chances to commute our algorithms into a product. So we started a very massive investigation of the market, in particular of the commercial software available, in order to check if our algorithms were able to provide something more. Here I show you two results of this investigation. The first one is associated with an object which is characterized by a moderate complexity. We are speaking about 5 million polygons. And as you can see, our algorithms are able to considerably reduce the computational time. So the gain factor in such a case is more than 8, while also we gain something in terms of accuracy here measured with respect to the rendering error. The second example is a definitely more complex object. Here we are speaking about 30 million polygons. Also in this case, our algorithms are able to perform the optimization with a not so bad rendering error, while most of the softwares available on the market do not succeed also in performing the optimization, so they crash before. So at the end of the story, Amazing Project survived. We got a second funding. We changed the name from Amazing to Adapta Studio. And on April 21, 2021, we founded our company, which is also a spin-off of Politecnico di Milano. A posteriori, we discovered that this date does also coincide with the day of foundation of Rome. So let's hope this is a good wish. Okay, so what about the founders? We have Leonardo Locatelli, myself, Francesco Clerici, the three pioneers. Then we have also Filippo Zanetti. He's a business angel that we met during the switch to product selection. He helped us a lot. Of course, we have the venture capital, so 360 Capital Partners, and then Polyhub. And I would like to take this occasion to thank Polyhub and also the viewers for the great help, the incredible help they provided us during all these months. Really, thanks. So, just to sum up, this is the mission of Adapta Studio. So we are supporting graphic designers and companies when they create their 3D assets with the hope to remain stuck to reality while reducing the weight in memory, so the computational resources. We are approaching the market, so we have devised different products in order to match the different needs of the market. Our products are called Amazed, and so far we have on the table 3 different products. We have an SDK library, which is the ideal tool for developers who want to include our algorithms in their own software. We have a SaaS cloud service plus an on-premise deployment who is suited for everybody who want to save on the local resources, thus moving the optimization in the cloud. And then we have a plugin for DCC and engines who represent the suited tool for graphic designers who want to include our numerical procedure into their standard workflow. A few months ago, we had also our own space, I would say the real Adapta Studio. So the inauguration took place on March 24. We are very close to Politecnico, by the way, 10 minutes on foot. And in the meantime, we turned 1 year old. The inhabitants of the studio are, okay, the 3 guys that you already know. Then we have Luca Mombelli and Matteo Carbonara. They both are mathematical engineering here at Politecnico. They both are a developer. And then we have Federico San Giorgio, who is a full-stack developer. He got his degree in software engineering at University of Catania. So a few words about the new challenges we are considering now. So we have extended Adapta algorithms to tackle the FBX files, which means animated 3D graphical object. Here you have a comparison between our original FBX. So I have to, oh no, sorry, I have to restart the movie. Okay, so at the beginning you have a number of polygons which is 11,000 and if I remember correctly 24 frames per second. This is the original configuration. After the employment of our algorithm, we are able to reduce the number of polygons to about 5,000. And in the meantime, we are able to increase the number of frames per second to 30. This means that we are lightening the weight in memory and gaining in terms of accuracy. And then, of course, we are approaching Metaverse, the new challenge. So the idea here is the following one. Each land in the metaverse has a limit, an upper bound, we would say, on the maximum number of polygons that you can host. Okay, so this limit is 10,000. So this means that if you do not optimize your object, your land will remain very poor, not so attractive to do virtual experience. If you're able to locate on your land many light objects, at that point the immersive experience will be incredible. So the idea is to use Adapta Studio algorithms in order to make these lands more crowded, in order to make your virtual experience more cool, I would say. And here you have 2 examples of our first experiments in the metaverse. On the left, we are in the metaverse, the Decentraland. So here, although our original chameleon consists of 2 250,000 polygons, we have been able to reduce our chameleon and to render the chameleon in the metaverse, in the central end, but not only, we have been able also to add people, clouds, trees, thus creating this scene. On the right, you have what we did in the metaverse OVR. Essentially, we bought the land around our Adapta studio. So now we have Adapta land in order to create a virtual experience for our future clients. And so, just to summarize, our suggestion is to be adaptive. This is the movie that you have on our web page. At the end of the day, this is the final official mascot of Adapta Studio, the chameleon, an example of adaptive animal in the nature. But this suggestion, my suggestion to be adaptive, is not so a novelty. We can come back to Charles Darwin. Essentially, in this sentence, the statement is not too different with respect to what I have just to say. And to conclude, I would like to wish to MOX happy birthday. And at this point, you can choose between the original cake or the diet one on the right. So make your choice. And thank you for your attention.
Many thanks, Simona, for this very nice talk and description of this great adventure.
Exactly.
Are there comments, curiosities? Do you want to enter in the metaverse? And,
no, thanks. Maybe in another day.
So thank you, Simona. Really very interesting. So a very silly question. When you talked about the metaverse, you said that there are... No, I know nothing about metaverse, of course. So my question is very local. You say you are only allowed to use a certain number of polygons, maximum number of polygons.
Yeah, on each land.
On each land. Why should they care about polygons? Why polygons?
Because polygons describe your object. So you cannot look...
In general. This is a kind of general metric that is used in the metaverse?
Yeah.
So how come that we are so fortunate to work on polygons before metaverse was introduced on polygons? Congratulations.
This is a difficult question, but indeed it is a good point. So at the beginning, we started to work only on video game, but this is a very, I would say, stiff world, all right? So it is not so easy to go there and say, okay, hello, this is our amazing software, try it and change what you are already using. So Metaverse seems to be more fluid, I would say. So since people is not so stuck in their scheme, probably we would have more chances to go in.
So if I understood, you showed examples, very striking examples on a representation of geometry, shapes, say. I presume that you can then also upgrade them to describe dynamics of those objects.
You can say again?
Use the same tools to describe dynamics.
Yeah.
And
an animated surface has more information that you have to manage. So the difficulty is there. So this format, FBX, which is the more widespread format for animated 3D object, actually contains additional information that you have to tackle when you reduce your object. So it is something, I mean, you start from the geometry, the first information, and then you have to add, for instance, the UV coordinates, which describe the texture. And then if your object is animated, you have to add the information relative to the animation. And all this information have to be managed together with the geometry reduction in order to preserve everything.
So the examples that you describe with this army of people moving, you mentioned that you were able to describe, I mean, to represent the dynamics with 30 frames per second. So in that case, how did you...
In that case, you are reducing the number of polygons, and at that point, you are able to use the polygon to increase the accuracy. So we are moving in an adaptive way the polygons where they are needed. So we get rid of many of the original polygons, but since they are located where they are actually needed, you are, as a byproduct, increasing the accuracy.
But then do you also have maps that connect the different frames in time?
Yes, no. There are the so-called bones, si chiamano? Bones, which are a sort of label that you have on your original 3D object, and the movement is essentially located there. Okay. So we had to learn how to manage these bones in order to make the reduced man, in this case, to move.
But you believe that it might also be a room for using models, differential models, to, say, move in time? Is that viable?
I don't know.
Well, maybe it's too early, I don't know.
Yeah. I do not see, I mean, to be honest, there are no PDs behind these, but there are estimators, so something that we learn.
So far you're based on estimator for purely geometric viewpoint.
We work on geometry, so estimators based on the geometry.
Okay, thank you very much.
You're welcome.
Okay. Are there other questions or comments? 1 and 2. Please.
Thank you for your presentation. Just for my curiosity, there is any company or use cases that is still using this kind of?
Thanks for the question. So far, currently there are about 70 people trying to play with our software. So we started a free tier, so a free company where you can try our software for 1 month for free, and you can perform in 1 month 100 optimization. So if somebody of you is interested, you can just drop us a line or go on the website. Currently we have about 70 people trying our software. Yeah.
Okay. Thank you.
You're welcome.
Sure. Or there are 2 further questions, one from Paola and the other on the other side of the room.
Thank you, Simona, for this very interesting question. I have a naive question. So, if I understood, so the objective is to minimize
is to reduce
the memory requirements while preserving the
exactly.
quality, right?
Exactly.
So I was wondering whether. So I'm assuming you are working with flat polygons, right? Or you can even deform that, and that's the question.
No, they are flat triangles describing your surface. Yeah.
So do you see a room, or maybe it's too expensive, whether to coarsen further and then to use a curved stuff?
We are thinking about to move towards the curved triangles. Okay, so it is not at the top of the to-do list, but it is something on the way. Yeah, so absolutely this would be interesting. Please.
Thank you very much. That is very curious what you were presenting, because it's very fascinating. As you know, in the planets we have some problem that we are trying to solve. And we face in the last 10, 15 years a huge amount of energy and ecological footprint invaded by the processing energy needed for the storage, the data storage, the information storage in these planets. And so it seems to me really that what you are doing is going to very important application in this field. And did you estimate at the end how, with this method, you could decrease the ecological footprint in terms of CO2, for example, due to that? Thank you very much.
Thanks. By the way, Alfio spoke about this issue this morning. We have an estimate of this quantity, and if I remember correctly, I asked to Leonardo for security. We have discovered that if we reduce of 1 giga our object, and then we use this object to do whatever we want, we are able to save 24 grams. So this is, I don't know if it is too much, too few. Anyway, this is what we discovered a few days ago because another people made a similar request to us, so we did the check. For MOX20, I will.
Okay.
Okay,
so
thanks.
If there are no further questions or comments, we thank again Simona.
Thanks to you.